one thing that I want to say before we begin is, well, I have a confession to make. The first one, so this isn't the first time I've given this speech. This presentation, I gave a version of it about a year and a half ago at an internal conference at Toronto. My confession is that it was a disaster. I bombed and I bombed pretty hard, and there were some pretty important people there, and I and I can't believe I'm still working here, but here I am. Anyway, so yeah, I don't know if I'm a fan of self-flagellation, or maybe I just want to prove that I can do a better job and not embarrass myself and the company. Here I am today, and to help prepare for this event, I turned to my first therapist for advice. So this is how that went.
Dr. Spatzel, by Creative Labs. Please enter your name. R-E-N-E. Hello, Rene. My name is Dr. Spatzel. I am here to help you. Say whatever is in your mind freely. Our conversation will be kept in strict confidence. Memory contents will be wiped off after you leave. So, tell me about your problems. You are what you are, Rene. And I thank you too. I will get parity error if you keep talking in this way. Move your hands off my keyboard. Parity.
I'm Rene Hidalgo. I'm a voice designer at Ubisoft Montreal. I've worked on the last 3 Assassin's Creeds, including the last one that just came out, AC Origins. So if you haven't picked up your copy yet, it's out in stores now. Hashtag shameless self-plug. And right now I am working on For Honor. So I want to thank you all for being here, especially for coming at a 1 o'clock meeting. Like who sets up meetings at 1 o'clock at work? Anyway, thank you all for being here, and also thank you very much to MIGS, the MIGS committee, and also to the technical support that we have here. So John, Ishmael, Brian, thank you very much. So yeah, and I'm excited to be here to talk to you about exciting developments in AI speech, and thanks for being here. So, isn't it such an amazing time to create and play video games? If there was a couch here, I'd be jumping on top of it like Tom Cruise on Oprah. When you think about the history of the universe and human civilization, think about the progress that we've made in this medium. It's kind of mind-blowing that we made this kind of progress in the span of just one lifetime. If you compare this, on the other hand, to film and television, not much has fundamentally changed. It's essentially they're still telling linear stories. Yes, there's 3D and all that stuff, and there's 4K, amazing, and surround sound and all that stuff, but we're still telling linear stories. Not that I'm saying anything bad about TV or movies. I love film and TV, but in video games, the interactive aspect changes everything, and the technology to affect how a story is told advances much more quickly. And we still have a long way to go to make our non-playable, our AI characters, known as non-playable characters or NPCs, not feel like robots. So the way forward for me is in eliminating constraints in production and transmission to create unique characters that feel truly alive. So today, in this talk, we are going to be doing a bit of time travel. We're going to go back in time for a little history lesson to see how for the longest time, humans, for some reason, have always been trying to reproduce the human voice. Then we're going to come back to today and look at the present challenges that we face as video game developers and creating dialogue. And then we will look ahead to the future for solutions on how for better video game dialogue and how the technology surrounding this will go far more reaching than that. So way back in the day, in the 13th century, we have our earliest recorded history of man's quest to reproduce the human voice. So in the 13th century, they had what were called brazen heads, which were essentially bronze heads that could allegedly talk, and they were thought to have mystical powers and were thus unsurprisingly deemed heretical by the church and destroyed as a result. And doesn't that kind of remind you a bit of this sequence in The Wizard of Oz? So on a side note, this is kind of what being a video game developer is about, in the sense that there's lots of smoke and mirrors, but it's really people, everything's just happening behind the scenes, pulling the strings. And when it comes to the voices that we hear, we're really just recording actors in a booth. So back to the history lesson. In 1769, a Hungarian inventor by the name of Wolfgang von Kempelen invented what is called the speaking machine. So he modeled the human vocal tract using bellows, a reed, and a simulated mouth. And even though it was monotone, it was capable of delivering vocal sounds across the human range. Then in 1845, an Austrian inventor by the name of Joseph Faber invented the euphonia, this creepy image that we see right here. So this was, of course, more sophisticated than von Kempelen's machine. It built on his tech, but this was also, for some reason, included a disembodied replica of a woman's head. It was capable of delivering a ghostly rendition of God Save the Queen, perfectly complementing its creepy aesthetic. Then, in 1939, almost 100 years later, we have our first encounter with electronically generated speech. Bell Labs invented what is called the voder, which synthesized the human voice by breaking it down into its acoustic components. So this required a highly skilled and highly trained operator to manipulate a keyboard, wrist bar, foot pedals, to modulate the pitch, vowel, nasal sounds, sibilants, and 10 bandpass filters. And we actually have a recording of this. This is what it sounded like.
Helen, will you have the voters say, "She saw me"? That sounded awfully flat. How about a little expression? Say the sentence in answer to these questions. Who saw you?
She saw me.
Whom did she see?
She saw me.
Well, did she see you or hear you?
She saw me.
Now, so far, you have only heard the voter speak in one voice. But the voter has other voices which he can use when Miss Harper makes a simple adjustment in his mechanism. Helen, will you have the voter say, "Greetings, everybody"?
Greetings, everybody.
Now, will you have him repeat that in a high voice?
Greetings, everybody.
And now in his best bass.
Greetings, everybody.
So what's incredible about this machine is the fact that the manipulations to modulate the tonality, inflection, and delivery of the voice are things that many modern text-to-speech engines can't even do, and this is almost 78 years later. Most synthesized speech, in many cases, still sounds like synthesized speech. So since the voter, Bell Labs continued extensive work in this field, along with advances in electronics. Like most technology, speech synthesis eventually made its way into the hands of consumers and gave us the speak and spell. Anyone else have this growing up as a kid? No one? Okay, there, oh, pretty good, nice. This technology also made its way into over things like phone systems, Dr. Spatzer that we saw right at the beginning, and many, many other applications. So it was just a matter of time before electronic speech generation would make its way over into video games. One of the first video games with speech was an arcade game by Taito called Stratovox, which was released in 1980. Then Space Spartans was released a year after by Intellivision, and was one of the first times where one of the first games that had speech synthesis on a home console. So this required the purchase of the IntelliVoice, which is the external speech module, synthesis module that we see right here. I had 2 kilobytes of read-only memory. Back then it cost $100, so adjusted for inflation, about $240. And this is an example of some speech from Space Spartans.
Mattel Electronics presents Space Spartans.
Hello, Commander. Computer reporting. Repairs on. Shield Plunder down under repair. Shield. Destroy battle computer 2/3 down under repair.
So before we continue, I just want to talk a bit about how there were three major ways to generate sound, and this will become clear in a couple of moments. So the first and primary way is to play back the sound from the sound source itself, so whether you're speaking or singing, playing a musical instrument. The second major way is to electronically simulate or create a sound through synthesis. Or the third method, which is playing back recordings of a sound source, which is also known as sampling. So when it was clear that when it was clear that synthesized speech was still not convincing, game developers turned to the third method, sampling, to give their games a more human feel. One early example of this was Joe Montana's Sports Talk Football. It's not the first. That was released in 1991, but it was the first game to have play-by-play commentary and used a technology known as Sports Talk. And it had a repository of about 500 lines.
Welcome to Joe Montana Sports Talk Football. A beauty. Takes it to the 10, 20, down at the 22, a 14-yard return. The kicking team comes on. It's first down. I can't believe it.
So that's not too bad, 1991. So while we have indeed come a long way in terms of video games and video game dialogue, we still have a lot of major obstacles to overcome, especially when it comes to making our characters feel really alive, and especially when it comes to systemic behaviors. Since really, when you think about it, since Joe Montana Sports Talk Football in 1991, nothing much has fundamentally changed as far as the principles of dialogue production for video games. Also, the available speech synthesis engines that are available to us today are still not usable.
Rene, are you still talking?
Yeah. So really, it's pretty bad, and we only really use this for prototyping and functionality testing. Sometimes it gets so bad that we get requests by higher ups to mute these voices, but at least for us, it's a way for us to know that the voices are there, they're playing. As a stark reminder for us to take these out as soon as we can. So we still take the sampling approach, but though on a much larger scale as consoles have gotten more powerful and store more memory, but the limitations remain the same. So we can only record a certain amount of lines, so that's due to many reasons. The two major reasons are due to budgetary restraints, so financial reasons, because it's pretty expensive to record actors. Also, there's only so many audio files we can store on disk. So this also means that we have a fixed number of voices. We can only record a certain amount of actors for our games, limiting our vocal diversity. So sometimes that's why you hear in games, like often you go to like different levels and you still hear the same dude, like in games like The Witcher, and even in Origins, like this is a common problem. So games have only gotten prettier, bigger, more complicated, and way more expensive. So just to give you all an idea of the challenges that we face for those who aren't familiar with dialogue production, one major challenge, which is an old classic, is repetition. So for those people who make realistic games, this is one of the cardinal sins that you try to avoid it, like the plague. So I'll show you all an example.
Wait, I know you. Wait, I know you. Wait, I know you. Wait, I know you. Wait, I know you.
So yeah, this is an extreme example, but this is a problem that we've been facing since the day we've been able to record voices and plug them into video games. Like I said, it's due to various budgetary reasons, disk space, and also managing how things get triggered. Another challenge that we face is goes back to one of the problems I mentioned in terms of having a fixed number of actors that we can record. So we try to introduce vocal diversity in various ways. So Black Desert Online kind of had a cool idea. So basically, we're just trying to make more with less, and try to diversify the content with the stuff we already have. So yeah, cool idea, but for me it sounds pretty unnatural, as is usually the case when you try just like straight up pitch shifting voices. So yeah, this is one of the big problems that we face. Another challenge that we face has more to do with games that emphasize realism and in open world game situations. I'll let you all have a listen and to get an idea of what I'm talking about.
Tell me about the ibis.
Medunimal.
Is he here?
He is the plague on the oasis. As you can see, the soldiers have become more brutal since he arrived. Before they got drunk and fought with the villagers. Now that Medunimal is here, they are disciplined and vicious.
So what's wrong with this scene? Yes? Yes, exactly. He should be yelling. He should be like you should hear when when the camel is bumpy, but you don't. And this is because in open world games, anything goes. You can walk. You can for a given sequence. You can walk. You can run. You can ride a horse. You can take a boat. You can ride a chariot, or just stand there and not do anything at all. So we could, in theory, if we had the budget, record multiple versions to take these into account. But already, at the bare minimum, this would double our budgets, which is something that we don't have. So yeah, we could. It's kind of like making and wearing underwear that's made out of $100 bills. Sure, you could use it, but it's a really expensive thing that not everyone is going to see, right? So yeah, it's not ideal right now. So yeah, in fact I worked on that game, so this is one of the things that frustrates me. But on the other hand, we can do some cool stuff, some real-time processing on our voices. Like I saw a couple of comments on YouTube. People make these videos, 40 cool details that you can see that you can find on Assassin's Creed Origins. And one of the comments that we had was concerning this.
What did that fool want with you?
Some visitors, having purchased religious objects, are angry when our village has no more dead cats to sell them.
Sorry.
What good fortune! I thought it would be years before we saw you again.
Hail in peace, Menehet. How is your family? Do not fear. Sekhmet will receive a fine tribute. We give...
So thankfully, this is kind of something that we took for granted on Assassin's Creed, because we just feel like whenever you change outfits, or like if something's covering your mouth, the sounds should change. So for us, it's like, yeah, okay, yeah, it's cool. And it wasn't even that difficult to do. So basically, depending on the outfit, we would enable certain states in Wise and enable certain plugins. And this had negligible performance hit. So Simon, thank you for Wise. Audiokinetic, you're awesome. Thank you very much. Other things we can do to expand the content that we already have is a method known as stitching. So this is taking recorded lines and chopping them into sentence fragments and replaying them in different combinations. So this is one way to expand how much one can say with existing content. And this isn't a new idea. Sports games like NHL and FIFA and NBA 2K have been doing this for years. Although to get that kind of quality, you need to record about 35,000 lines, and that's just between the commentator and the color guy. So when we're talking about a game like Assassin's Creed, we're talking about 60 different voice actors playing over 300 characters. So it's not exactly. Maybe for certain games this could work, but also when it comes to stitching, recording is a lot trickier, because you have to make sure that when you chop up these that there's a consistency, so that when you recombine the sentence fragments, they flow well. So this also means that you have to edit things very precisely so that the flow between the segments works well also. So editing takes longer, and as we know, time costs money. So physical modeling is modifying the shape and texture of a voice based on its physical characteristics, like breathiness, grittiness, that kind of thing. We're only recently starting to see runtime solutions for this. So like a company like Krotos has come out with Dehumanizer Live, which is a plugin for Wise. I know it just released, so if there's anyone who had experience with this plugin, I'd love to hear your thoughts and also to see how it runs on your games. But from what I understand, these kinds of plugins come at a heavy computational cost that our current consoles can't handle. And one of the biggest problems with these, not problems, but limitations is that they can't modulate the expressiveness and delivery of how lines are spoken. Another thing we can do with audio data is to use it to push animation states, for instance. So there's an application called Beyond Verbal, whose algorithms are used to break down the emotional content of voice recordings. So you could technically use this data to map out emotional states based on a file's emotional content. And on Assassin's Creed Origins, one of the things we did was we had this dictionary where if if characters said certain words, it would trigger certain gestures. So if a character would say me or I, they would point to themselves. If they said the name of a location, they could point somewhere. But this is a more systemic way and more precise way to do it. So like all these solutions, these methods that I mentioned, we still have a lot of limitations. So looking forward to the future, what does this mean? How can we keep going at this rate as games are getting more complicated, but we still want to get better NPC behaviors and believability? Well, I see a future where we break free from all the production and technical constraints that I just mentioned, where things like line counts aren't even a thing. I see a future where we have unlimited voices. I see a future where NPCs have agency and can truly think and feel on their own. And I see a future where NPCs really feel alive. So how do we get there? So kind of like how VR is a stopgap to direct-to-brain entertainment, like all the methods that I just mentioned before are really just stopgaps to advanced speech synthesis. So this is where AI characters can generate speech on the fly. They will react in real time, never saying the same thing twice, where you can modulate the intention, musicality, intensity, emotional content, basically the expressiveness of a voice in real time. But of course, this brings up a lot of legal and security issues, as you can imagine, now that we are in the age of fake news. Also, this could heavily impact things like our actor contracts. So we could technically create new content for an actor without even bringing them into a recording studio. And basically actors are paid per recording session. So this will, I think, this could really impact how contract negotiations will go moving forward. But also, it could also mean that an actor can license their voice and get paid and not even step into a studio. So win-win until we don't have to bring actors in at all and generate new voices. And anyway, so yeah, even though we have things like Siri, Alexa, and Cortana, they're still not ready for games as far as I know. In order to, we have unsupportable tech constraints, like consoles can't handle this kind of technology while running the game at the same time. So at least for now, we're still a bit away from a runtime solution. So a bit of news. Last year, Google's DeepMind introduced Wavenet. They introduced Wavenet. So this is basically a way to, they are breaking the current paradigm of text-to-speech. So I'll talk a bit about the paradigm of text-to-speech, which is basically falls under two major categories. The first is concatenative speech text-to-speech, which is Think of this as a more granular version of stitching. So instead of chopping recordings into sentence fragments, we're chopping them into short speech samples known as phonemes. And these are some examples.
The Blue Lagoon is a 1980 American romance and adventure film directed by Randall Kleiser. Aspects of the sublime in English poetry and painting, 1770 to 1850.
The other method is known as parametric text-to-speech, which is essentially speech synthesized, generated from scratch practically.
The Blue Lagoon is a 1980 American romance and adventure film directed by Robert Kleiser. Aspects of the sublime in English poetry and painting, 1770 to 1850.
So again, we see this dichotomy between a seemingly never-ending battle between sampling and synthesis. So concatenated text-to-speech is the method that is most commonly used. This is because it sounds a lot more natural, but this does entail a lot more recordings. We're talking at least 20 hours of recordings with a trained voice talent. But one of the major limitations of this is that you can't modulate expression. Parametric text-to-speech, on the other hand, requires minimal to no recordings at all. You can modulate expression, but as we just heard, it's not that natural. So Wavenet. Wavenet is essentially a deep learning model trained on hours of audio, and it generates raw waveforms directly at the sample level. So this model still uses speech synthesis principles, which is it's constantly making predictions that a given sample will be played next by what has played before, but it does this at a super fine level that we haven't really seen up until now. And it's kind of, for me, I'm not a quantum physicist or anything, but it seems to me like one of those quantum mechanics principles where a particle can become a wave, and a wave is a particle at the same time, kind of thing. So if you compare this to the last text-to-speech examples, this is what it sounds like when you generate audio with Wavenet.
The Blue Lagoon is a 1980 American romance and adventure film directed by Randall Kleiser. Aspects of the sublime in English poetry and painting, 1770 to 1850.
You can even generate audio with no text.
Sådan. Ved du, hvad jeg siger? Jeg står til mig, but den er til mig. Sit så det jeg det den der går kan det give så. I'm plus.
So they just tag pictures and tell. Så det til sådan. Sit some.
Yeah, it sounds kind of weird, but I mean, it still sounds like someone's talking, and it picks up even details such as breathing and little clicks that people make when they talk. And with a model like this, you can essentially create the crowd ambient sounds, also known as walla.
So just tag.
Take note also very
Another cool thing that you can do with Wavenet are things like voice templates, which is essentially overlaying someone's voice on another person's performance.
The avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
The avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
The avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
The avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
And just to prove that it's the same performance,
the avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
So you could technically have a situation where one day someone with a lot of money, and I've always wanted to be in movies and video games, could pay someone to like maybe Daniel Day-Lewis would do it for a certain amount of money, and then he would pay the production company to use his voice in a video game. You could also, maybe someone can build an app where you can take your favorite line from a movie and replace it with your very own. So you guys can take that idea, it's for free, and good luck on your startup. So Wavenet also can generate music as well. So yeah, so Wavenet can do some pretty cool stuff. And when people talk about, oh, machine learning, neural networks, blah, 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 like this is the kind of thing that they're talking about. So since last year, Google has improved its model about 1,000-fold, and it's reached a point where it has been able to deploy its voices on Google Assistant, where you can try it out in US English and Japanese. And when it was first released last year, it took about 2 minutes to generate 0.2 seconds of audio, or 2 minutes to generate 2 seconds of audio. Now it can generate sounds in 2 seconds of audio in just 0.1 seconds. I'm sure some of you have seen Adobe Voco. For those who haven't, this is, it's kind of, think of this as a kind of Photoshop for voice.
We can actually type something that's not here. So I heard that actually on that day, Michael actually kissed our Jordan. So sorry. To recover the truth, let's do it. So let's remove the word "my" here.
Your secret's out, Jordan.
And just type the word Jordan.
Ooh.
And here we go.
And I kissed Jordan and my dogs.
So where Wavenet needs about 20 hours of recorded speech to get that kind of quality, apparently Adobe Voco just needs 20 minutes of audio to do these kinds of manipulations and generate speech. And is anyone here from a local startup, Lyrebird? Anyone? No? Okay. So Lyrebird is a local company that apparently can do this kind of thing in a minute. So, so it's pretty cool, this kind of technology, but also pretty scary in the era of fake news. So as we have seen, Wavenet models show a lot of promise with deep machine learning. I can see us maybe take conditioning models based on the physical characteristics of humans. So you would essentially associate the sonic characteristics of a voice with the vocal tract composition and construction by maybe taking a voice print and modeling it on MRIs of patients on speakers' vocals tracts. And maybe one day when people are modeling 3D characters, someone could also model their vocal system. So things like their lungs, vocal cords, throat, mouth, nasal cavities to create unique and distinct voices without even recording anything. And something like this also shows promise as well, just because like there's a company called Vocal ID, which gives non-speakers a true voice. So maybe by taking like CAT scans and MRIs of people who can't speak, they'll be able to really provide their real voice, so they can speak with how they would be if they were able to talk. So all this stuff is really cool. The technology is amazing, and it's advancing very quickly, but there's still something missing. And because it doesn't mean anything, all this doesn't really mean anything in terms of video games if a character is still a robot with no feelings. And this is where artificial psychology comes in. So where AI focuses on decisions NPCs make, I still feel that we need to make more advances as far on the psychological front, because NPCs with feelings, so NPCs, how NPCs feel are really what will help NPCs really feel alive. So something like a psychology engine would be the thing that would modulate and drive the emotional content of speech, synthesized speech. So we could, like one approach we could take is to take renowned psychologist Robert Plutchik's Wheel of Emotions, which outlines all of the spectrum of basic human feelings. His model and his framework doesn't just cover the range of basic emotions, but it also shows how they can be combined to create complex emotions, conflict, and what is a good story without drama. So the way I see a psychological framework being constructed is that you would take inputs like the stimulus that's happening in a game. Also, you would take the context of what's happening around a character. So whether it's time of day, where they are, what they're doing physically, You would also take their history and experience as well. This would all be processed by the logic layer and also the emotional layer. And it's really this interaction between the logic and emotional layer that will give emotions and reactions that are not just true to a situation that's happening in a game, but also true to a character. And this is especially important because people have different reactions to the same situation. So this could also imply that narrative designers will also be designing backstories for characters. So all of this is to help our interactions feel more real so that we can connect with our characters and stories on a much deeper level. So in order for all this to happen, we need the following technologies accessible at a consumer level. So things like cloud speed and capacity. I'm pretty sure one day, sometime soon, I don't know when, but they will overtake the processing power of consoles. And so maybe when that happens, the box in your living room won't do the bulk of the processing. If we still have boxes in the living room, I don't know. And much like how graphics processing units, also known as GPUs, are dedicated to rendering and making games look beautiful, okay, we get it, games look amazing, but we also need to maybe have chips just dedicated to AI processing as well. Of course, with advancements in neural networks and machine learning, we'll have more sophisticated ways of creation and also more sophisticated AI behaviors. And one of the holy grails of computing, quantum computing, will turn all of the above on its head and change everything. This is especially pertinent because I feel that the non-binary paradigm of quantum mechanics is more in line with the complex nuances of human behavior, but I'm just a voice designer, I'm not a psychologist or a quantum physicist. So as we know, when it comes to entertainment, it's not just about brains. Sure, faster and more sophisticated machine learning, raw audio speech synthesis, it's impressive, it's amazing. And yes, speech will have the capacity to be more adaptive, but the thing that will modulate the expression is still missing. So like, it's a little cheesy, but I love this quote anyway. Maya Angelou once said that I've learned that people will forget what you said, people will forget what you did, but people will never forget how you made them feel, which is why it's also about heart. So we need to be looking beyond intelligence, and also we need to look at the psychological aspects of our AI characters, because the meaningful experiences that we have come from how we connect with each other and eventually our interactive characters. And all of this comes from feeling and emotion. So when characters have their own living and breathing personalities, we will enter a new world of entertainment and interaction, the likes of which we're only starting to get glimpses of right now. So I don't know if some of you heard about Sophia the robot, who was recently approved as a citizen of Saudi Arabia. So that's happening right now. It's kind of crazy, but but also just about the presentation. It was scripted, so people freaking out about that presentation. It was scripted, okay, and she still sounds like a robot, but it's still like crazy what's happening. So at the same time, as these new worlds open up, we are entering scary unknown times. As I mentioned before, fake news is already a big problem, and some of the tech that I mentioned here could be part of what pushes it over. There are tremendous security and ethical considerations that developers need to make when building these systems. This also brings new questions as far as what this means for interactions between humans. What does this mean for interactions between humans and machines? And what does this also mean for machine-to-machine interactions? Hopefully, you'll design these machines with empathy, please, because hopefully, when it comes to machine interactions, they won't decide that we are suddenly expendable. This also brings up points like, what does it mean to be a sentient being? What does it mean to be alive? What does it mean to have a soul? Can robots have souls? That kind of thing. And do we want the potential of having hyper-intelligent beings that could also be psychologically imbalanced? The thing is, the tech is coming. It's just a matter of time. So that's why it's also, when it comes time to face these issues, it'll take a bit of courage. So we are right at the cusp of seeing major technological breakthroughs that will not just affect the way we make games and how we produce dialogue for video games, but they will have the potential to change our everyday lives. And we'll be doing things that we didn't even know were possible. So at least when it comes to digital entertainment, we could keep on making the same kind of games. And some of us should, because there's a time and place for everything. Or we could also step into the unknown with a bit of courage and push the boundaries of possibility. Thank you. Questions? Yes. With that. With the hat, yes.
It seems to me one of the other challenges that could present itself in advancing this technology into games would be the multilingual user scenarios and the need for a very robust globalization layer to ensure that you have parity across languages, just given the importance of revenues. A lot of this technology, whether it's, I believe, voice recognition is optimized for English, but far from it in other target languages.
Yeah, absolutely. Yeah, I completely agree. So I'm pretty sure, like, pretty much these models just need tons and tons of data. So it's just a matter of making sure that we get people recorded. Yeah, like I completely agree. And I don't think that's even an issue, really. This is something that's going to happen anyway. And I think that this will also level the playing field for a lot of countries that need this kind of technology. So, yeah, I agree. Yes, with the red sweater.
The time that you mentioned to create the voices with the Google Tech.
Yes.
I assume that was with an already trained neural network, right?
Yes, absolutely.
Do you have an idea of the size of the data set and the time to train the said neural network?
I know it required 20 hours of recorded speech. How long it took to train the network, I'm not sure. I don't know. Yeah. CJ, guy with the,
Rene.
Hey.
Excellent talk. Thank you very much. It was a fascinating sort of look at where we're going. The question that I have for you, and it may be a bit outside of the scope of perhaps your responsibilities within the company, but you talk about synthesizing human voice and imbuing it with agency and personality.
Yeah.
Do you think that the types of games that we make will necessarily need to change once those innovations happen, because largely we will spend our time murdering those characters?
Well, this is why, like, when people start introducing this kind of technology in the games, like where people actually have agency and personality and maybe are considered real, maybe people will think twice about killing these characters. Maybe we'll feel more empathy for them. Who knows? All I know is that, like, whenever new technology gets introduced, people go nuts. So, yeah, I don't know. I'm sure that it might probably make people uncomfortable, and maybe we'll still want to keep making the same kinds of games, but yeah, it could go either way.
So really. You think we might have to pass through the just because we can before we get to the maybe we shouldn't, or perhaps because we could?
Well, yeah, I think that's where it's going to go. Like, we're going to do it just because we can, as people do with new technology.
Excellent. Thank you.
Anyone else? Yes. Oh, they have a mic to bring to you. Yes.
You mentioned the quantum computing.
Yes.
Are you using it yet, or is that something still in the future?
Oh, it's still in the future as far as I know. Right now, I think what you can do, IBM has a website which is connected to their quantum computers, and it's the way they design it. It's kind of crazy. It looks like something from Bill Nye's lab. It's not commercially available yet, as far as I know. It's still going to be, I think, a bit of a while before that becomes accessible at the consumer level.
Is the expectation from a gaming perspective that this type of computer will allow for, like in close range to what this gentleman just said, completely autonomous characters in a way?
I think that's where it's going, and it's only a matter of time. And that's why it's kind of scary. It's kind of scary where this could go, but it's going to happen. It's just a matter of time. And that's why like it's important that that these systems are designed ethically, but like now that the tech world is like completely lacking in ethics. So yeah, this is like Facebook and Twitter, even those applications are completely devoid of ethics, like because their whole job is to just exploit users and keep them on their sites as much as possible. So I don't see, and there's really no one can really get punished per se on well, I guess I don't know. It's a really complex issue that I don't know. I'm not really. It's scary, is what I want to say. Yes.
As well, thanks for the talk. It's amazing. As you're speaking about the future and predicting the future,
right.
And considering that everything you just said means that many voice actors will be out of business and many studios that record voice actors will also need to change stuff. When do you think we'll start seeing these technologies becoming common in video games?
Becoming common, I want to say 10 years, but things are moving so crazy fast. I don't want to bet any money on that, just because it's insane how fast things go. And yeah, I worry about that too, because I've made friends through this industry with actors and people at the recording studios. I don't want to see them lose work either, but maybe the business model will change. Like I said, maybe actors can license their voice and get paid without even working per se. So that's one way around it. And I think people, kind of like how people always want vinyl, I think will still want, especially characters or actors that people really love. I don't think they'll go out of work. So I don't know. It's in that sense, like I don't think it will level the playing field at all.
All right.
Yeah.
Thanks.
Anyone else? All right. Thank you so much, everyone.